Hi, welcome to my channel Industry 4.0. Today, in this video, we'll study the fallback function in Solidity intimately. Please like and share the video and subscribe to my channel. So, let's start the video. The Solidity fallback function is executed if no one of the opposite functions matches the function identifier. It is executed if no data was given the call. Just one unnamed function is frequently assigned to a contract. It's executed whenever the contract receives plain ether with no data. The fallback function must be marked payable to receive ether and add it to the entire balance of the contract. Description: a contract may have at the most one fallback function. It is declared using fallback, external, payable. This function cannot have arguments. It may not return anything and must have external visibility. If none of the opposite functions matches the given function signature, it's executed on a call to the contract. It may be executed if no data was supplied in the least and there's no receive ether function. The fallback function remains to receive data. But so as to also receive ether, it must be marked payable. Like any function, the callback function can execute complex operations as long as there's enough gas passed on there too. In the worst case, if a payable fallback function is additionally utilized in place of a receive function, it can only believe 2300 gas being available. Features: the fallback function may be a special function available to a contract. It's the subsequent features. It is called when a non-existent function is named on the contract. Required to be marked external. Has no name. Has no arguments. Can't return anything. It is often defined together per contract. It'll throw an exception if the contract receives plain ether without data if not marked payable. Example: Pragma Solidity 0.5.0. Contract test. Uint public x. Function, external, x equals 1. Contract sync. Function, external payable. Contract caller. Function call test, test, public returns, bool. Bool success equals address, test, dot call, ABI dot encode with signature, non-existing function. Require, success. // test.x is now one address payable test payable equals address, uint 160, address, test, / sending ether to check contract. // the transfer will fail, i.e. this returns false here. Return, test payable.send, to ether. Function call sync, sync, public returns, bool. Address payable sync payable equals address, sync. Return, sync payable.send, to ether. Execution. Fallback functions in Solidity are executed when a function identifier doesn't match any of the available functions during a smart contract, or if there was no data supplied in the least. They're unnamed. They can't accept arguments. They can't return anything. There can only ever be one callback function during a smart contract. In short, they're a security valve of sorts. Solidity developers designed a default design choice with fallback functions. That's importantly interesting because fallback functions are executed if a specific contract receives plain ether by no other data associated with the transaction. This default design choice is sensible and supports protect users. However, counting on our use case, it's going to be critical that our smart contract receive plain ether via a fallback function. To do this, the fallback function must comprise the payable modifier. Contract example: contract function, payable. The contract will issue an exception and return the ether to the sender if there's no payable fallback function. Therefore, the contract receives plain ether with no other data. The fallback function may only believe 2300 gas being available. This doesn't have much room to do other operations. Other operations like writing to storage, creating contracts, calling external functions, and sending ether. Hence, fallback functions must be simplistic and easy. One may still use message data to retrieve any payload furnished with the decision even though the fallback function cannot have arguments. We'll use ABI.decode alongside the array slice syntax to decode ABI encoded data. C D equals ABI.decode, message data, for smiley face UN256, UN256, after having checked the primary 4 bytes of message data. Note that this could only be used as a final resort and proper functions should be used instead. Pragma Solidity 0.6.1. Pragma Solidity 0.6.1. Pragma Solidity 0.6.10.7.0, contract test. // this function is called for all messages sent to / this contract, there is no other function. / sending ether to this contract will cause an exception. / because the fallback function does not have the payable. / modifier. Fallback, external, x equals 1. Uint x. Contract test payable. / this function is called for all messages sent to / this contract, except plain ether transfers. / there is no other function except the receive function. / any call with non-empty call data to this contract will execute. / the fallback function, even if ether is sent along with the call. Fallback, external payable, x equals 1, y equals message value, / this function is called for plain ether transfers, i.e. / for every call with empty call data. Receive, external payable, x equals 2, y equals message value. Uint x. Uint y. Contract caller. Function call test, public returns, bool. Bool success equals address, test, dot call, ABI.encode with signature, non-existing function. Require, success. / results in test.x, becoming equals 1. / address, test, will not allow to call send directly, since test has no payable. / fallback function. / it has to be converted to the address payable type to even allow calling send on it. Address payable test payable equals payable, address, test, / if someone sends ether to that contract. / the transfer will fail, i.e. this returns false here. Return test payable.send, to ether. Function call test payable test, public returns, bool. Bool success equals address, test, dot call, ABI.encode with signature, non-existing function. Require, success. / results in test.x, becoming equals 1 and test.y becoming 0. Success equals address, test, dot call, value, 1, ABI.encode with signature, non-existing function. Require, success. / results in test.x, becoming equals 1 and test.y becoming 1. / if someone sends ether to that contract, the receive function in test payable will be called. Require, address, test, dot send, to ether. / results in test.x, becoming equals 2 and test.y becoming 2 ether.